Hello, Trio Upward Bound. Now that we have we're getting to the point of having our baseline information, we're going to have to be figuring out how we are going to be going forward with our step count. Okay, so we have just a practice problem here for percent change. And so we're going to be looking at it. Is it exponential? Is it linear growth? What kind of growth are we having over this time of changing our steps? So this problem reads, student A's baseline average of steps for week 0, or T, were 2,356 steps per day. Student A must increase her weekly average by 5% each week for 3 weeks. The average steps walked can be modeled by a function n, which depends on the week t. How many steps should she be averaging by week 4? Okay, so like I said, we have her average right now per day during the week is going to be 2,356 steps. Okay, so I'm going to put steps per day just to kind of keep myself straight. And this is just an average, okay? So with that, I have this n of t, right? This is my function that they said I'm going to be using. So I'm going to create a t chart, just like you saw in the videos, right? So I'm going to create that. So I have t over here. So t is my time, right? Or my what week I'm going to be focusing on. So we have 0, because that's our baseline data, right? That's week 0. And then I have week 1, 2, 3, and 4, because I put how many steps should she be averaging by week 4? Okay, so we know that when 0 or t is 0, we are at 2,356. Okay, so this is n of t. Okay. So next, to set up our next equation, we need to know what we're increasing by. So what we're increasing by is 5%. Okay, so I have 5% that I need to increase. Okay, but I'm still going to keep the full amount, right? So, or I could look at this as 105%, right? So with that, I need to change it. So I'm going to change this over into a decimal. So now I'm put at 1.05, not 1.5, 1.05. Okay, move your decimal over 2 places. Okay, so now that I know what I'm increasing by, this number here, I need to multiply this number with this, right? So it's going to look like this. So for week 1, we have 2,356 times 1.05. Okay. So then that would equal, so I do the math, right? Handy dandy calculator. You don't have to do this by hand or anything, obviously. So when I look at that, that comes out to 2,473 point something. So we will just go ahead and round it up. So you can't take point of a step. So we're going to round it up to 4. Okay, so by week 1, I need to be taking 2,000, or student A needs to be taking 2,474 steps per day of that week. Okay, so then I'm just going to go on and create my equations for the next ones. So this next equation, I'm going to take my base data, so 2,356 times 1.05, but we see that we're on week 2, right? So we need to square this, or else I'm going to come up with the same answer, but we need to square it to get that next one. So then here, I would take my base data, times it by 1.05, but cube it, because for week 3. Okay, same thing with week 4, 2,354 times 1.05 to the 4th. Okay, and we can continue to do this all, say we were continuing and we set our goal for ourselves, to continue going forth, and we want to say, okay, by, September, count our weeks, and we could see by September 1st how many steps we should be taking per day. So we could continue and going on, and we would just change this exponent here. Okay, so once you calculate all of your points or your steps per day, per week, okay, so we're going to take that and we're going to plot it. So you're going to be using the digital graph paper to make it a little bit easier on you. I hope it does. So for now, I'm just going to be using pen and paper. Okay, so remember, this is your X, this is your Y. So I create my graph here. It's just going to be a rough sketch. And then I have my X here. So here's my X, here's my Y. We have 0, then we have 1, 2, 3, 4. So obviously yours is going to be online, so it's going to be a little more accurate in terms of your spacing and whatnot. So then for my Y, I'm going to just go ahead and go by 500s. Okay, so I'm going to start here. I'm going to say this is 500, 1,000, 1,500, 2,000, 2,500, and we'll go here to 3,000. Okay, so there's my X and Y axes. Okay, so then I'm going to start plotting. Okay, so I know that when 0, okay, when our baseline, okay, week 0, that would be at 2,356. So I'm going to say that's about somewhere there. Okay, so there's my week 0. Week 1, I know that I'm about 2,474, so I'm going to come up. We're probably maybe about there, right? We're probably pretty close to that 2,500 dash. So then I'm going to continue to plot, and I should see a graph, that's kind of looking like that, right? So now our question is, okay, based on our videos that we watch, based on what we see in our data here, based on our numbers, is this going to be a linear graph, or is this going to be an exponential? Okay, so if it's linear, why? Okay, also, if you think it's exponential, why? Okay, what is the difference between a linear and exponential graph and equation? What do we see in the difference? Okay, so that's our question to ask ourselves. Now that we see our information here in our practice, what kind of growth are we going to see? Is it going to be linear growth or exponential growth? All right, guys, I hope this video helped you to kind of at least see what you were expected to do and kind of the setup. So that way tomorrow on Friday, when you do your own steps and you're calculating your increase, you know what to do and kind of what to expect. If you guys have any questions, please send me a text, email, whatever works, phone call. Let me know. Good luck.